Welcome to EduAmp. This is a GCSE physics lesson. Now, to go with that, what we're doing is this video is all about acceleration velocity time graph. I'm probably only deal with this part first in this video here, and then velocity time we're done in a separate video. So I would like you to be able to explain the difference between velocity and speed, and then calculate acceleration using an equation. Now, you'll find all this is in your book at page 152 under chapter 5b, and it's all under title, obviously, acceleration. So here you go, two wonderful year 10 students, and you can decide who they look like. Yeah, it has to be Harry, this one, anyway. Anyway, year 10 students have now recently passed the driving test and now driving a car. Now, they're going down the motorway. So you can have this one here, which is going to be, looks like Harry, where you want to be, going along this speed here. And I'm going to say, we're going to do at 30 meters per second. This person here, nice young lady, is traveling this way here. And she's also, let's say, she's doing 30 meters per second. So they're approaching each other at the same speed. Now, this is a common thing going through. Remember, speed is going to be our good old scalar quantity. So basically, they can have a magnitude, how fast they're going. But what I can do then is bring in the idea of velocity. And we mentioned this in our last video, which is going to be the vector quantity, which means it has got size and direction. So the size I've already mentioned is 30 meters per second. But now what I'm doing is I've got to give a direction. So no matter which way you do it, I can say this is going to be positive and that's going to be negative. So I mean by that is going to this way, it's going to be positive, and going the opposite direction is going to be negative. So therefore, to show a direction, I can have a positive and negative, or I could say this one is going to the right and this one's going to the left. Sometimes we use negative signs, which makes it interesting then, because won't I have a approach speed? Therefore, the difference between these two numbers end up being 60 meters per second. Therefore, they approach each other at a speed of 60 meters per second. And that's where the vector quantity comes in to allow us to work that out. Hope you're happy with that. Now, we were doing some practical work in ticker timers, but unfortunately, we're not in at the moment, so we couldn't do it. Not to worry. Therefore, what is acceleration? Well, taking the lovely lady, it's a very strange purple wig she's got on. But anyway, here she goes. Purpley blue. I don't know where her colour is. Anyway, here she's going on, and I said she was travelling in this direction over here. Now, if she, say, example, started off where she was stationary, what I can do is a little timeline like this, where I'm saying here's time 0, 1 second, 2 seconds, and 3 seconds. So let's say at 0, she's travelling at 0 meters per second. At 1 second, she's travelling at 3 meters per second. At 2 seconds, she's going to be 6 meters per second. And at 3 seconds, then she's going to be travelling at 9 meters per second. What I mean by that is she's obviously accelerating because she's getting faster. But isn't her speed changing? And we say this is a delta V, which is a change in speed, is going to be 3 meters per second. And that's going to be every second. Does that make sense? Therefore, it goes up by steps of 3. Therefore, what it means is she has got a acceleration of 3 meters per second. In other words, the acceleration is 3 meters per second squared. And that's where this weird unit comes from. In other words, her acceleration is going up by 3 meters per second every single second. If it's going to be 6 meters per second squared, it will go 0, 6, 12, 18. Therefore, what it does, it gives us an equation that acceleration equals delta V over t. What I mean by that, that is the change in time. Sorry, change in velocity. Therefore, that is measured in meters per second, and this is measured in seconds, which gives the weird units of acceleration going to be 3 meters per second squared. And this is a formula, I'm afraid you're going to have to learn this one. It's not given to you in the horrible, nasty exams. So I'll get that written into your book, but you also find it in your book under page 152. So, rubbing this out of the way to create a bit more space for me, this is a calculation showing how you do it. You've got a car accelerates from 2 meters per second to 28 meters per second in 6 seconds. What is the acceleration? So what you do is you write down your formula, and remember we're using formula, working, answer, units, and there's the formula. So then to work out your change in velocity, well, the change of velocity is going to be 28 minus 2, because that's going to be your final speed and that's going to be your initial speed. Then it does it in 6 seconds. And we can all do this now. What you can do then is you take your 28 minus your 2, and then you get your 26 over 6. Okay, 26 over 6, we all know then equals 4 and 2, 6, which is exactly the same as 4 as a third, or you can write down as that as 4.3 meters per second squared. So all you do is take change of velocity, 28 minus 2, divided by the time taken, 26 over 6, then gives us 4.3 meters per second squared. Just shown the formula, I've shown my working, I've shown my answer, and I've also got the units as well.